All right, example 4 from 9.2 in Math 20-1. Last example for this section. And really, it's very similar to the other examples we've done. It just gives us, again, a bit of an uglier or more complex quadratic to work with. Right off the bat, I want to answer this question, though. It says, why is the quadratic expression greater than 0? This particular inequality is modeling a baseball that's in flight. In flight really tells us that the height of the baseball must be greater than or equal to 0. And you can make a pretty solid argument that it really should just be greater than 0, because if the baseball is on the ground, is it really in flight? I mean, it was in flight, but now it's hitting the ground and it's no longer true. A couple important things just before we get going. We're going to need our calculator for this, but I do want to identify that we are still going to graph y equals negative 4.9 t squared plus 15t plus 2. And then we're going to find the intervals of t where our function, and maybe I'll just put y is greater than 0. Sorry, I messed it up. I had it right. And maybe, now that I'm talking about the variables we use, just because I put y over here, I'm going to put y is greater than 0. In flight occurs when y is greater than 0 as well. So that does make sense why y has to be greater than 0. Some other important ideas about this graph is that a is equal to negative 4.9, so it has to open down. My y-intercept is at 0, 2. But what also is pretty important is that, as cool as it sounds, we cannot throw a baseball back in time. So as soon as we talk about this object being thrown, we know that our t has to be greater than or equal to 0. And again, there's a pretty solid argument that should t really be equal to 0? And I would argue that the moment that it's out of the hand, time starts. So at a t of 0, it's like a nanometer off my hand. So I would say that t equals 0 is valid for this question. What we need to do then is we need to determine, and I want to show you that sometimes this is one of those things that's kind of actually easy to do without a calculator. Knowing that it opens down and it has a y-intercept at positive 2, if the y-intercept is right here, we know that it opens down. A lot of students struggle with the idea that is it this function or is it this function? Because both of those satisfy the idea that, a is negative and we have a y-intercept of 2. The best way of determining that is using your calculator. And as much as it does, I don't know, suck's not the right word, but as much as it can be a little tedious to use our calculator for something like that, it is really beneficial because it does it perfectly, right? As long as we type it in perfectly, I suppose. So hopefully you still have your calculator. Grab it now, and we are going to put in for y1, negative 4.9. We have to use x, not t. So negative 4.9 x squared plus 15x plus 2. Now, because we do have 0 on one side, I'm going to leave y2 blank. That's going to, behave as our x-axis. The windows, though, the windows make a big difference. Now, time can't be negative, but I like seeing that scale, that axis. So I'm going to make x min -1. I doubt that this baseball is in the air for 10 seconds, but we'll leave it as is. I do know that y min being negative 15 is overkill. Right, this baseball is not in flight when it's in the ground. Y max at 15. I mean, you can kind of see the preview down here on my calculator. We know that that works. I would probably honestly have chosen 20, and then I would have tried the graph. So this blue parabola is the height of my baseball, and we don't have to change it, but man, that's a lot of wasted space. And we can see that this actually hits after 1, 2, 3, so like 3.2 seconds, give or take. I'm not completely sure what it is. I'm going to tweak my window setting, and I'm going to make my x max 5, just because I do like to get a pretty reasonable, view of what this baseball is actually doing. And if you've ever had a chance to, watch somebody throw a baseball from the stands or golf or any sport that involves a projectile, you're probably going to notice that it doesn't look exactly like this. Not part of the question, but this particular question is ignoring air resistance. Again, not all that important, but it would change the physics and make it a little more realistic if we considered it. Now, it wants to know during what time interval the baseball is in flight. Keep in mind that t can't be negative. So it's going to be from 0 to wherever that point is right there. Now, I'm going to find that point by using second calc. That's going to be my 0. It's an x-intercept. That's to the left of it. That's okay. I'm going to have to cursor all the way until I'm to the right. Can be just to the right. One thing that I always encourage the students is look at the bottom of your screen. It is telling you where your cursor is. I am to the right of this x-intercept when my y becomes negative. and then the guess, as long as it's in between my bounds, doesn't particularly matter. And I get, oh, I was close. I said 3.2, but it's not quite that. Now I'm going to cheat a little bit, and I'm actually going to take that whole thing and put it into my smartboard file here. Because what we're going to do is we're going to use that graph and basically interpret what it's telling us. I'll just put it over top of my old crappy graph there. Now, looking at this information, my function, the blue line, is above 0 from, I mean, technically, it's this x-intercept and beyond. But one thing that's really important is we identify that t must be greater than or equal to 0. So none of this actually exists. The baseball is not in height when x is negative. So it's actually going to be this point right here, and I'm going to put it beside it. That's 0, 2, which means that this baseball is in the air when t is greater than or equal to 0, but less than 3.1892. Typically, questions like this will tell you where to round. We usually do nearest hundredth or nearest thousandth. So just to make sure we see it, if it did ask for the nearest thousandth, I would put 3.189. If it asked for the nearest hundredth, now one thing that I do have to be careful of is I think I'm reading too much into this question. Because the question asked us to solve this inequality right there, I should not have greater than or equal to 0 there. Because that function is not greater, well, no, when t is 0, the height is greater than 0. Never mind, that needs to be there. Now, the point that I'm getting at here is if I took negative 4.9 t squared plus 15t plus 2 and said that it was greater than 0, look what happens when I put t is equal to 0 in. This would be 0, this would be 0, and I would get that 2 is greater than 0. Is that true? Yes. So t equals 0 is part of the solution. Now, if I were to put 3.1892, I would get that 0 is greater than 0, which is not true. And that's why we have that different inequality symbol there. That is a bit of a dirty trick. You know, problems in math that involve a real world context can be trickier because that sometimes does, I don't know if break is the right word, but it sometimes changes some of those rules that we like to memorize and apply to, math question after math question after math question. Okay, definitely don't be afraid to use your calculator in this section. Even the first couple examples that we factored, you should use your calculator to kind of confirm your graph. And I'll put up the standard assignment, but please do check Google Classroom because we are modifying them, doing these kind of the digital days here. All right, make sure you do email if you have any problems. This is something that, is very, very practicable, but I understand that it takes a lot of time, so you do have to commit to that.